Perseverance, nicknamed Percy, is a car-sized Mars rover designed to explore Jezero crater on Mars as part of NASA's Mars 2020 mission. It was manufactured by the Jet Propulsion Laboratory and launched on 30 July 2020 at 11:50 UTC. Confirmation that the rover successfully landed on Mars was received on 18 February 2021 at 20:55 UTC. As of 26 February 2021, Perseverance has been on Mars for 8 sols, 8 Earth days. Perseverance has a similar design to its predecessor rover, Curiosity, from which it was moderately upgraded. It carries 7 primary payload instruments, 19 cameras, and 2 microphones. The rover is also carrying the mini-helicopter Ingenuity, an experimental aircraft that will attempt the first powered flight on another planet. The rover's goals include identifying ancient Martian environments capable of supporting life, seeking out evidence if microbial life existed in those environments, collecting rock and soil samples to store on the Martian surface, and testing oxygen production from the Martian atmosphere to prepare for future crewed missions. The Perseverance rover has 4 science objectives that support the Mars exploration program's science goals: looking for habitability, identify past environments that were capable of supporting microbial life, seeking biosignatures, seek signs of possible past microbial life in those habitable environments, particularly in specific rock types known to preserve signs over time, caching samples, collect core rock and regolith, soil, samples and store them on the Martian surface, preparing for humans, test oxygen production from the Martian atmosphere. Despite the high-profile success of the Curiosity rover landing in August 2012, NASA's Mars exploration program was in a state of uncertainty in the early 2010s. Budget cuts forced NASA to pull out of a planned collaboration with the European Space Agency, which included a rover mission. By the summer of 2012, a program that had been launching a mission to Mars every 2 years suddenly found itself with no missions approved after 2013. In 2011, the Planetary Science Decadal Survey, a report from the National Academies of Sciences, Engineering, and Medicine, containing an influential set of recommendations made by the planetary science community, stated that the top priority of NASA's planetary exploration program in the decade between 2013 and 2022 should be to begin a Mars Sample Return Campaign, a 3-mission project to collect, launch, and safely return samples of the Martian surface to Earth. The report stated that NASA should invest in a sample caching rover as the first step in this effort, with the goal of keeping costs under $2.5 billion. After the success of the Curiosity rover and in response to the recommendations of the Decadal Survey, NASA announced its intent to launch a new Mars rover mission by 2020 at the American Geophysical Union Conference in December 2012. Though initially hesitant to commit to an ambitious sample caching capability and subsequent follow-on missions, a NASA-convened science definition team for the Mars 2020 project released a report in July 2013 that the mission should select and store a compelling suite of samples in a returnable cache.
The Perseverance design evolved from its predecessor, the Curiosity rover. The 2 rovers share a similar body plan, landing system, cruise stage, and power system, but the design was improved in several ways for Perseverance. Engineers designed the rover wheels to be more robust than Curiosity's wheels, which have sustained some damage. Perseverance has thicker, more durable aluminum wheels, with reduced width and a greater diameter, 52.5 centimeters, 20.7 in, than Curiosity's 50 centimeters, 20 in, wheels. The aluminum wheels are covered with cleats for traction and curved titanium spokes for springy support. Like Curiosity, the rover includes a robotic arm, although Perseverance's arm is longer and stronger, measuring 2.1 meters, 6 feet 11 in. The arm hosts an elaborate rock coring and sampling mechanism to store geologic samples from the Martian surface in sterile caching tubes. The combination of larger instruments, new sampling and caching system, and modified wheels makes Perseverance heavier, weighing 1,025 kilograms, 2,260 pounds, compared to Curiosity at 899 kilograms, 1,982 pounds, a 14% increase. The rover's radioisotope thermoelectric power generator, MMRTG, has a mass of 45 kilograms, 99 pounds, and uses 4.8 kilograms, 11 pounds, of plutonium-238 oxide as its power source. The natural decay of plutonium-238, which has a half-life of 87.7 years, gives off heat which is converted to electricity approximately 110 watts at launch. This will decrease over time as its power source decays. The MMRTG charges 2 lithium-ion rechargeable batteries which power the rover's activities, and must be recharged periodically. Unlike solar panels, the MMRTG provides engineers with significant flexibility in operating the rover's instruments even at night, during dust storms, and through winter. The rover's computer uses the BAE Systems RAD750 radiation-hardened single-board computer, based on a ruggedized PowerPC G3 microprocessor, PowerPC 750. The computer contains 128 megabytes of volatile DRAM, and runs at 133 MHz. The flight software runs on the Xworks operating system, is written in C, and is able to access 4 GB of NAND non-volatile memory on a separate card. Perseverance relies on 3 antennas for telemetry, all of which are relayed through craft currently in orbit around Mars. The primary ultra-high frequency UHF antenna can send data from the rover at a maximum rate of 2 megabits per second. 2 slower X-band antennas provide communications redundancy. JPL built a copy of the Perseverance that stayed on Earth. Called Optimism, Operational Perseverance Twin for integration of mechanisms and instruments sent to Mars, it is housed at the JPL Mars Yard, and is used to test operational procedures and to aid in problem solving should any issues arise with Perseverance. Also traveling with Perseverance is the Mars helicopter experiment named Ingenuity. This solar-powered helicopter drone has a mass of 1.8 kilograms, 4.0 pounds. It will demonstrate flight stability and the potential to scout for ideal driving routes for the rover over its planned 30 Martian Day, 31 Earth Day, experimental flight test window. If Ingenuity survives its first cold Martian nights, where temperatures dip as low as 90 degrees centigrade 130 degrees Fahrenheit, the team will proceed with the first powered flight of an aircraft on another planet. Other than a camera, it carries no scientific instruments. Associate Administrator of NASA's Science Mission Directorate, Thomas Zurbuchen, selected the name Perseverance, following a nationwide K-12 student Name the Rover contest that attracted more than 28,000 proposals. A 7th grade student, Alexander Mather from Lake Braddock Secondary School in Burke, Virginia, submitted the winning entry at the Jet Propulsion Laboratory. In addition to the honor of naming the rover, Mather and his family were invited to NASA's Kennedy Space Center to watch the rover's July 2020 launch from Cape Canaveral Air Force Station, CCAFS, in Florida. Mather wrote in his winning essay,
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. We are always curious, and seek opportunity. We have the spirit and insight to explore the Moon, Mars, and beyond. But, if rovers are to be the qualities of us as a race, we miss the most important thing. Perseverance. We as humans evolved as creatures who could learn to adapt to any situation, no matter how harsh. We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere. We, not as a nation but as humans, will not give up. The human race will always persevere into the future.
The Perseverance rover lifted off successfully on 30 July 2020 at 11:50 UTC aboard a United Launch Alliance Atlas V launch vehicle from Space Launch Complex 41 at Cape Canaveral Air Force Station, CCAFS, in Florida. The rover took about 7 months to travel to Mars and made its landing in Jezero crater on 18 February 2021 to begin its science phase.
The successful landing of Perseverance in Jezero crater was announced at 20:55 UTC on 18 February 2021, the signal from Mars taking 11 minutes to arrive at Earth. The rover touched down at 18.4447 degrees N 77.4508 degrees E, roughly 1 kilometer (0.62 mi) southeast of the center of its 7.7 times 6.6 kilometers. 4.8 times 4.1 mi wide landing ellipse. The landing was more accurate than any previous Mars landing, a feat enabled by the experience gained from Curiosity's landing and the use of new steering technology. One such new technology is terrain relative navigation, TRN, a technique in which the rover compares images of the surface taken during its descent with reference maps, allowing it to make last-minute adjustments to its course. The rover also uses the images to select a safe landing site at the last minute, allowing it to land in relatively hazardous terrain. This enables it to land much closer to its science objectives than previous missions, which all had to use a landing ellipse devoid of hazards. The landing occurred in the late afternoon, with the first images taken at 15:53 and 58 seconds on the mission clock, local mean solar time. The landing took place shortly after Mars passed through its northern vernal equinox, LS equals 5.2 degrees, at the start of the astronomical spring, the equivalent of the end of March on Earth. The parachute descent of the Perseverance rover was photographed by the HiRISE high-resolution camera on the Mars Reconnaissance Orbiter, MRO. NASA considered nearly 60 proposals for rover instrumentation. On 31 July 2014, NASA announced the 7 instruments that would make up the payload for the rover. Planetary Instrument for X-ray Lithochemistry, PIXL, an X-ray fluorescence spectrometer to determine the fine-scale elemental composition of Martian surface materials. Radar Imager for Mars Subsurface Experiment, RIMFAX, a ground-penetrating radar to image different ground densities, structural layers, buried rocks, meteorites, and detect underground water ice and salty brine at 10 meters (33 feet) depth. The RIMFAX is being provided by the Norwegian Defence Research Establishment, FFI. Mars Environmental Dynamics Analyzer, MEDA, a set of sensors that measure temperature, wind speed and direction, pressure, relative humidity, radiation, and dust particle size and shape. It is provided by Spain's Centro de Astrobiología. Mars Oxygen ISRO Experiment, MOXIE, an exploration technology investigation that will produce a small amount of oxygen, O2, from Martian atmospheric carbon dioxide, CO2. This technology could be scaled up in the future for human life support or to make the rocket fuel for return missions. SuperCam, an instrument suite that can provide imaging, chemical composition analysis, and mineralogy in rocks and regolith from a distance. It is an upgraded version of the ChemCam on the Curiosity rover, but with 2 lasers and 4 spectrometers that will allow it to remotely identify biosignatures and assess the past habitability. Los Alamos National Laboratory, the Research Institute in Astrophysics and Planetology, IRAP, in France, the French Space Agency, CNES, the University of Hawaii, and the University of Valladolid in Spain cooperated in the SuperCam's development and manufacture. MastCam-Z, a stereoscopic imaging system with the ability to zoom. Scanning habitable environments with Raman and luminescence for organics and chemicals, SHERLOC, an ultraviolet Raman spectrometer that uses fine-scale imaging and an ultraviolet UV laser to determine fine-scale mineralogy and detect organic compounds. There are additional cameras and 2 audio microphones, the first working microphones on Mars, that will be used for engineering support during landing, driving, and collecting samples. NASA plans to invest roughly $2.75 billion in the project over 11 years, including $2.2 billion for the development and build of the hardware, $243 million for launch services, and $291 million for 2.5 years of mission operations. Adjusted for inflation, Perseverance is NASA's 6th most expensive robotic planetary mission, though it is cheaper than its predecessor, Curiosity. Perseverance benefited from spare hardware and build-to-print designs from the Curiosity mission, which helped reduce development costs and saved probably tens of millions, if not $100 million, according to Mars 2020 Deputy Chief Engineer Keith Comeau. Please like and subscribe to our channel for more videos like this. Thanks for watching. Please don't forget to like, share and subscribe.